Welcome to the 64-bit edition of the Security Tube Linux Assembly Expert course and certification. Now in this video, we will look at creating a 64-bit exit shellcode. Now, what we will see is that the basic exit syscall, which we call using RAX and RDI, ends up having a lot of nulls or 0x00 in the machine code. As we've discussed in the last video, we need to remove these nulls and change the instructions in such a way that 0x00 or null does not appear in the shellcode. So let's jump right in. Now I have exit.nasm, which is really just the exit syscall, right? So if we go ahead and assemble and link this, rather even with just the object file, you can now use object dump and look at exit.o. Now as you can clearly see that there are a lot of nulls or zeros basically in this shellcode, right? And this is something which we need to take care of. So how do we do that? Well, the idea is to now replace these instructions with equivalent ones such that we do not end up getting nulls. So let's give it a shot. So we could do azor rax. Rather, let me create a new file and copy exit.nasm into it just so that we can see an evolution rather than just replacing the first one. And move rax60, let's replace it with zor rax. This is going to zero out rax, and then you can just do a move al 60. Right? Now we are moving 11 as the return value in RDI, but really we can just return 0, right? Which means we can just change this to zor RDI. Right? Now let's go ahead, assemble this. Now let's use object dump on this file. And now as you can clearly see that the nulls have been removed entirely. Now to create shellcode from this, we need to extract these bytes 48, 31, C0, B0, 3C, blah, 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 up to 05. And as you can imagine, doing this manually is going to be a pain. And this is where we can use some amount of automation where you can go to commandline-foo.com and grab some of these quick command shortcuts with which you can get the shell code out of the binary using object dump. So here is one, and then here is another one which is there. So I'm going to go ahead and grab this one, copy it, go in there, paste it. So the binary needs to be replaced with either the binary or the object file. Both are equivalent. There we go. Now we have our shellcode all cleanly pasted out. We do not need the -m intel. Could just remove that comfortably. So this makes it a little bit more smaller, which is also pointed out by someone here in the comment section, as you can clearly see. Right? So now let's copy this shellcode and let's copy shellcode.c from the previous video. Let's open it up, replace this with our shellcode we just created. And then let's use GCC compile it. Then we can run /shellcode. And as you can see, just an exit shellcode, it's going to exit. And it's of size length 10. Now, the best part is that there isn't like a set way to do this. So you could always copy exit2.nasm into exit3.nasm and think about other things you can do. So as an example, rather than XOR RDI, why not just go ahead and move RAX into RDI? And why not add 60, which I'll leave basically to you. We could do this as well. Now we can look at object dump. Look at exit3.o. And as you can see, now we have another shellcode in here, or another variant rather, which we can pick up. So this was for exit2.o, and this one would be for exit3.o. Right, as you can clearly see, there are some changes in here, but no nulls, which is good. So we can copy this, open up shellcode.c, and replace this in here as well. Run this, and again we go ahead and get shellcode of size 10. So really what I'm getting to is there is no set way of converting an assembly language equivalent into small compact shellcode, which removes bad characters like 0x00, right? As you practice more and more, you should be able to locate instructions which are shorter in machine code, and that's eventually what you would get used to in creating shellcode. I've given you the links for the command line foo website in here so that you can go and copy it and extract the shellcode for the object dump utility. That's all for this video, and if you're enjoying your time here at Pentester Academy, then please do consider recommending us to your friends and colleagues in the InfoSec community. Thank you.